Okay, 1, 2, 3, all eyes on me. If you haven't finished labeling, hold off on it. We're going to talk about the pink assignment next. You have your assignment and your notes. Let's talk about where we're getting to in order to do our second objective. I will apply the factor by grouping method by first identifying the common binomial. That's what we did first. And then our second part is finding the greatest common factor. So in this next assignment, we're kind of working backwards towards this factor by grouping so that we can figure out this other. Our goal is to figure out this other because you guys are able to do everything else that we did last week. Okay? Look at the first assignment, the first part. It says, what do you notice about polynomials in numbers 1 through 14? So look at your assignments 1 through 14. The next sentence might give you a clue. When you see blank terms, you may want to factor out the greatest common factor. So when we're talking about polynomials, we have to know how many terms there are. So go ahead and see. What do you observe about numbers 1 through 14? So talking about polynomials. So in your notes, numbers 1 through 14, what do you observe? What did you observe? What did you write in the sentence?
I noticed that numbers 1 through 14 have 4 terms.
Very good. So I like what Dana did. She wrote in a complete sentence. She wrote, I noticed that in numbers 1 through 14, there are 4 terms. So please don't just write 4. I want you to write it in a complete sentence. So if you were able to teach this to someone else, they would understand it. So that helps us with the next part. When you see 4 terms, so write the number 4. You may want to try factor out the greatest common factor from the first 2 terms and then factor out the GCF from the last 2 terms. So what does that mean? Look at your notes. In problem number 1, I'm going to look at the first 2 terms. I'm going to take out the greatest common factor. What's the greatest common factor of n cubed and 4n squared? N squared. And if we were to think about the distributive property, inside the parentheses would need to be n plus 4. And if we take a look at the last 2 terms, 3n plus 12, what's the greatest common factor? 3. And what would go inside the parentheses? This part right here, does this look familiar? Yes. This part right here, does it look familiar?
Yes.
Look at your last assignment.
Yes.
Yes? Why?
Because they have the same common.
Ariana? I hear it. Very good. The inside the parentheses is what you would highlight. So inside, for the next part of your notes, please write n plus 4. And what's left over? N squared plus 3. So we're working backwards here. This is where I showed you last time. From here to here. From this polynomial to this product of binomials. Okay? So now we're looking at 4 terms. And what we're going to do is we're going to take out the greatest common factor. And what you're going to see is that you can factor out the n plus 4. Okay, look at number 2. Look at number 2. What would be the common binomial? What would be in the first parenthesis?
N minus 3.
N minus 3. Okay, write it down. And what's left over?
N squared
N
plus
squared plus 8.
N squared plus 8. Because I factored out, I took the greatest common factor of the first 2 terms, and then the greatest common factor out of the next 2 terms. Look at number 3. What would I factor out first?
5n plus 2.
5n plus 2, and what's left over?
2n squared plus 3.
Plus 3. Okay, so we're not going to have a lot of time. I'm going to ask that you do numbers 4 through 8. Go ahead and do numbers 4 through 8.
4 through 8.
Numbers 4 through 8. You can do this in your notebook. Show your work. We're going to staple both of them inside your notebook anyway. So